Okay, hello students. Dr. Hawley again, broadcasting to you this time from one of the so-called ARC ships on the open ocean. We've had another viral outbreak, and so we're escaping from the hordes of the infected. And this is not too dissimilar from sort of thing that happened with the COVID outbreak. You may recall decades ago, or maybe centuries ago. As you know, we lost all the records in the purge. But I want to talk to you today about Python and sort of a Python review. And to do that, I'm going to share screen and I'm going to navigate towards the GitHub page for this site. And this video is not going to, we're not going to go through every single thing on the Python, but I'm going to walk you through some of it. So I'm going to go to share screen. And there we go. And now you're seeing, so I'm on a Linux system and this is my web browser and it's in dark mode. Hope that's okay. And so here we are, github.com, my username, and then DLAIE, Deep Learning AI Ethics. I used to work at an institute called AEI, and so I'm continually typing in the wrong URL and thinking that GitHub deleted the course. But here it is. Now, for those actually enrolled in the course at Belmont, we have additional content on Blackboard, praise Blackboard. But this is where we'll also be hosting a lot of things, okay? And so I know I promised a video on how the course is going to work, and some of this is laid out here, but I still have about 3 weeks left to figure that stuff out, so I'm not going to commit. So, but I do want to go over kind of the Python review part of that. And so under lessons, which you can get to either there or up here under lessons, right? And so, well, first of all, from our previous time, hopefully you took a look at this. We'll look at this real quick. The not all ML is DL. And as I mentioned, trying to view this stuff in GitHub, it doesn't render a bunch of stuff. So there's a bunch of stuff missing. And so you want to click the Open in Collab button. Although I've noticed if you left click, nothing interesting happens, at least not on my system. And so instead, you need to go back and do like the right click or the control click. And then when you're in Collab, which is what we're going to be using for everything for this course, again, I have dark mode, you may have light mode. Then you can see everything. You can see the videos, right? There's something from Oxford. There's Jeremy Howard. I want you to watch these and learn. There's some screwing around with Wekinator. And oh yeah, okay, we'll work on that. Still have a few weeks left. But there's the basic idea, all right? So what I want to do today, actually, so you can do that, I want to go over the Python review, which, all right, so on GitHub, it looks like this, which is okay, but there's some stuff missing. And so there are a few points I want to hit. You're going to read it and go through it, and there's some exercises for you, but I want to add a little extra context. And so here we are. You know what? I have no idea if this font is big enough for you to see, but if you click on it and follow along yourself, then it should be big enough. Tell you what, I'm going to go for super big, just in case, all right? And so this is a review. I had a link to learnpython.org. That's how I learned Python back in the day. And yeah, so there are a number of things that are going to be taken care of for us that we're not going to need to worry about, but I'm still going to try and cover various things that you're likely to see at some point, okay? And so this is kind of the quick summary. As I mentioned, this document's got longer and more comprehensive than I originally intended. So really a few key points about Python that I think are interesting and worth noting, especially if you're coming from any other languages. Some things about the Jupyter notebooks or the Collab notebooks that we're going to be using. A few things about NumPy, particularly like array ops and list comprehensions and loops and writing fast Python code. Now, later on in the notebook, there's some timing exercises, and it's a good puzzle, an exercise for you to do, but just in case, I don't want you to get too discouraged or too worried about the timing stuff. If that ends up scary for some of you, just don't stick with the course, okay? And then, yeah, some other things that I think are particularly useful. And then there's some exercises at the bottom, all right? And so these are really these bullet points. So there's a lot of stuff in this notebook, as we say, but these, whatever, 6 points are kind of the things that I think are most important, all right? And so key points about Python. Python is like Play-Doh. It's ideal for messing around. So here I'm quoting myself, right? Because I spent a lot of time programming, and this may be different from your background, but I spent a lot of time in strongly typed declarative languages where you're pre-allocating and post-allocating things, and they're great and they're fast. C, C++, Java, that kind of stuff. But it really kept me from understanding this key thing about Python. Not only is it an interpreter-based language, but because of that, it's extremely well suited for messing around. And so, one of the best playgrounds for messing around is the so-called Jupyter notebook environment, which these Collab notebooks are all based off of. Okay, so yeah, there's a lot of stuff that we can do and change things around. It's very, very mutable. Okay, everything is mutable, everything is overridable, everything is extendable, and this can be both a blessing and a curse. And so for a while, I got stuck on the curse part. But yeah, you can do what you want within limits. Okay. Now, as far as production code, usually what happens is people figure out kind of the prototype in Python, and then in many cases for production kind of code, it'll get rewritten often by somebody else into C++, whether we're talking audio apps or business applications or really high speed video processing or something like that. All right. Other thing to note, Python's really not secure. Okay, so it's good for playing around, but it can allow other people to play around as well. So yeah, I would not use Python in security conscious applications. All right. Great thing about Python. And so I guess I started learning Python, I don't know, maybe 12 years ago. And I noticed that there was always a library or a package for anything you want to do. Somebody else has probably already written most of what you want to do. And so I think that's been a key to the rapid adoption of Python. Writing fast Python, if you're coming from other languages that have really sophisticated compilers, Python is not that, and Python has a reputation for being slow, but that's really just, I think, for people that aren't used to writing Python and they try to write something in Python the way they would in a different language, and yeah, it's going to be slow. In particular, writing for loops is going to be slow. But there are ways to write things fast, and that's kind of some of what I emphasize later on in the notebook is if we can think Pythonically, then we can be fast. And why do we care about fast? Well, for deep learning applications, we're going to be doing lots and lots or gajillions of calculations. And so the difference between microseconds and milliseconds can mean the difference between, you getting an answer to a homework problem in a few minutes and a few days. And that's why we're going to use Collab that will give us access to Google's GPUs, graphics processing units. A lot of the things, if you try to do it on an ordinary CPU, or you try and do it like on your Mac laptop, it'll take forever. And then you get something with a GPU and everything's at least 100 times faster. And deep learning is about lots and lots and lots of calculations. It's very number crunchy. Yeah, I'm throwing in pictures of things just to spice up the lesson. Okay, so when you're first starting out, it's easy to accidentally write slow code. And again, I don't want you guys to freak out too much about whether it's slow or fast. Usually what we do is, we can write something slow and make sure it's right, and then backtrack and figure out how to rewrite it so it's fast. That's the way I usually work, is I don't always write everything fastest from the get-go, all right? But if you can think in terms of vectorized operations, we'll talk a bit about what that means, and kind of one-liners. There are these things called list comprehensions, which are usually very fast, okay? And so, yeah, we're going to talk about speedy ways of it's all about phrasing things in Python, all right? That may not come intuitively at first, but it will. So, yeah, we mentioned these Jupyter notebooks and Collab, and so I spent a lot of time just writing raw Python code in text editors. I use Atom editor quite a bit, right? And if you're set up on your own computer or your own cloud thing, that's fine. But Collab is gonna be where we do all our work because I'm canceled by Netflix, and so for $10 a month for Netflix, I'm now a Collab Pro user. But you all are probably just regular free Collab users, just like Google Docs and Google Sheets. We've got Google Collab, and so yeah, you could do all these things in either the command line or an IDE like PyCharm, but we're going to do everything in Collab. And Collab and Jupyter. Jupyter has been around longer than Collab, but they're compatible in many ways, not all ways. But I'm going to try and do things for this course in a way that it's all compatible. Okay, so when I say Jupyter notebooks, I mean like this kind of file. There are other places that you can run. For example, a little plug for Paper Space Gradient. They've really done a good job of getting like full Jupyter compatibility, and you can run on there for free. But I'm going to assume that we're on Collab just because it's convenient for a lot of people. All right. And so a few key concepts. There's this notion of Python. The Python interpreter is called the REPL, which stands for REPL. Cell navigation, where we have these different cells. We've got our text, and then we've got some areas where we have code, and we can execute the code. And we can execute the code either by pressing the little play button, or as in with Jupyter notebooks, we can do Shift and Enter. So Shift, hold down the Shift key, press Enter, and boom, it executed. All right, we got a little 13 there because I've actually been running this for a little while. If I had started it all over again, that would say 1. All right, so imports, packages, and modules, right? We usually import these packages other people have written, and there's different ways that we import things, right? We can give something a new name. Like usually we don't use NumPy, just by convention, it gets abbreviated to NP. And so we can import sub things. Here I'm actually importing the same thing 2 different ways just to illustrate how that goes down. Question of how we make our own Python packages, something we could talk about later. For now, we're just going to do imports, right? And so we're going to be making a lot of use of NumPy and PyTorch. We're going to use some FastAI and some other packages as well. And I've been kind of putting some stuff together in a little library that I'm calling Mrs. Puff, after the, I won't say the name of the trademarked TV show on YouTube. But as far as having a school at the bottom of the ocean, I consider that deep learning, right? So I'm putting some stuff in there. Right now, there's not a whole lot in Mrs. Puff, but I'll keep adding to it. And that'll just be kind of a way of consolidating some of the things we're going to do in the course, all right? And debugging libraries, we can integrate those. Zach Mueller and Hugging Face have just in the past few weeks released some debugging that's pretty fun. All right, so a lot of times we'll be in Python, and we can on Collab, and just make sure that we can import what we need. And a lot of times when we want to do things on the Unix command line underbelly of Collab, we can start with a exclamation point. So exclamation point means do a Unix command, and so this is a pip, which installs packages. So a lot of times you'll see this exclamation point pip, and then install this, and then this little thing, that's just something I add. You won't, not everybody does this. That's the pipe symbol, and then grep-v means don't show any of this. A lot of times you install things and you get a bunch of lines about this package is already installed, and so adding this little piece just means we don't see a ton of lines that say this is already installed. Okay, so just doing that, it looks like we're able to run pretty okay. All right, and so then I go down through. Again, I'm not going to read off every little thing on this, but I do want you to go down and read through it yourself and run the code. Some things about NumPy. And so in particular with NumPy, we're going to deal with arrays. So arrays are kind of like Python lists, except there's a little bit of extra stuff. It's pretty simple to make an array. You're declaring a Python list, in this case, 1, 2, 3, 4, 5, 6, and then just casting it as an array. And you can cast it as different data types, like we could tell it that these are supposed to be ints or float 32s or other things like that. So let's just run this and look at this. Okay, so we got some things here and different ways of declaring arrays. A range is something I use quite a bit. It makes an array with the counts. It's actually these two things do the same thing, although note that a range starts at 0 and ends at 5. So instead of going 1 through 6, it's 0 through 5. Python is a 0 indexing kind of language. And then there's some special array creation things, like if you want ones or zeros, there's this thing called I, which is supposed to be like the identity matrix, which is usually capital I. And some clever people at NumPy decided on a little pun there for I. And so that's like ones along the diagonal and zeros everywhere else. And you can make random arrays and things. And arrays have shape. Shape is super duper important for deep learning because so often we're going to be multiplying things and combining things, and we want to make sure that the shapes agree. And so anytime you want to know what's the shape of this array, it has this property of dot shape, whatever the name of the array is. You're going to use that quite a bit. All right. And then we've got, various operations. And whether we're NumPy or PyTorch, a lot of these are reproduced in both languages and things. So things like means and absolute values, and we can take things along. If we've got like a two-dimensional array, we can have one axis or the other axis, and transposing matrices and so forth, right? Okay, so the vectorizing is the key, and that's where we, instead of trying to index individual elements, we treat the whole array as one big thing. And so, for example, just if we want to time some operations, we can just kind of, in the notebook, we can do a little %%, which is a special kind of Jupyter magic, they call it, and it'll invoke a timing of the next thing that happens. And then this is actually all this output is telling us about. It runs the loop a whole bunch of times. And so this is like let's say this is a fairly fast way of doing something. Whereas if we write out a couple of loops, I mentioned loops are slow in Python, and the point here, so this said it was 15.1 milliseconds per loop, and it was finished pretty fast. And here we are, this is actually doing the same thing as the one above, and we're still waiting on it to complete. So the whole point of this little exercise is just to say, hey, yeah, if you can treat arrays as single objects, then then it will go better for you. And then, so we'll just let that keep going for a little while. This is kind of an egregious example. Okay, 5.5 seconds. So we went from 15 milliseconds to 5 seconds. Now multiply that by like 1,000 or 1,000,000. That's how long you're waiting to get your answer. All right. Slicing is another important thing from NumPy, right? Where we can kind of slice along one axis or another axis, and that's usually done through the colon. And the colon just kind of means like everything along this axis. So if it's like a two-dimensional array, so let's say we're counting from 0 to 11, and it has this 2D shape, and then we can say, okay, :2 means that we're actually going to get the number 2 column, which is like, this is column 0, this is column 1, this is column 2. So we get the 2, the 6, and the 10. Right? And we can add axes to things if we want. The -1 refers to the last thing, and so that's a handy thing to do. And you can reverse an array by having a colon, and a -1, so everything is backwards, right? So slicing, that's usually called a view, and when we slice things or we use views, they're not regenerated as whole new arrays. They're just a kind of a projection into that array or from that array, and that's pretty fast. Okay, so we can do that a lot. All right, and note that indices, when you're slicing, whoops, those can only be integers. You can't have like floating point indices. All right, and then broadcasting is really another key concept where if you've got like a big array and a small array, broadcasting is where the small array is like copied a bunch of times until it has the matching dimensions of the big array, and then boom, whole big vectorized operation happens. And so, for example, if we're trying to combine a couple things, we can take a scalar like 5, which is just a single number, and this array, which is A, which is this thing up here, this 2D array. We can just add 5 to all of those. So imagine adding 5 to each of those elements, and that's all there. All right. But if we try and add like that array with some other array that doesn't have the same dimensions, it says operands cannot be broadcast because we have these two different shapes and they don't match up. Right. So what can we do? Well, interestingly enough, we can have an array. So it's 3 by 4 was this array. If we have an array that matches the 3, it'll actually copy that a whole bunch of times. Hang on a second, I labeled that wrong. I'm going to fix that right now. Okay, I'll have to re-up this into GitHub, but yeah. So because the number of columns match up, so it's the last number. The last number on this one has to match the last number on there, which is going to have a shape of 4. As long as those agree, you can broadcast. All right, so yeah, I say there the last dimension has to match up. Okay, have a few things to say about random numbers and seed, and essentially you can have things be different every time, or you can have reproducible results every time. And so generally I say as we're developing the code, it's good to specify a seed manually so that as you change the code, you know that it's not just the random part that's changing. But then later on, or kind of as you go, you do want to allow it to randomly have different seeds all the time. Talk a bit about functions and methods and arguments and keyword arguments. You probably know all that, right? I'm not going to make you write lambda functions, but if you see a lambda is just a function with no name. And we are going to make some use of generators. Generators are just a function that it has the word yield instead of return, and it kind of remembers where it was when you were using it. But I think our generators are generally going to be under the hood. So I'd say don't worry too much about generators. Classes, we're generally going to be using other people's classes. And so, right, a class, you've got the name class or the word class and the name, and then sometimes there's like in PyTorch, we'll have like nn.module here a lot. And so class is usually, right, if you've done a bunch of things and you're like, hey, it'd be kind of nice if all of these things are kind of packaged together in one thing. Like when I was doing the Mrs. Puff stuff, I'll sometimes create, once I've done enough little routines, I'm like, these would all kind of go together in one big thing and define a class that'll hold all that. And so you can have variables in a class. You can have some functions in a class. Those are usually called methods. And all the class variables and methods are accessible through the dot. So it's like Q, I call this Q is my class. All the classes have a underscore, underscore, init, underscore, underscore, which is the thing that gets called when you first invoke the class, right? And then you can do some other things with it. And then certainly there's lots of data types. We're going to make a lot of use of tuples. Something I like to do with tuples is do multiple assignment on the same line. I can just kind of save you some lines of code. Lists are super important. And we're going to use lists for lots of things. When we're using some of the fast AI libraries, they've defined this extra thing in their fast core library called L. And L is kind of like a supercharged list that can do some extra things. Otherwise, it's just like an ordinary Python list. We've got dictionaries or dicts. These are really important as well. If you've ever used pandas, pandas is kind of like Excel for Python, but it's all based on dictionaries or dicts. And this gets used quite a bit. They're kind of like lists, but the order doesn't matter. Instead of having integer indices, we've got keywords. And so we define it with curly braces. And then like if you say a bracket Japan, you get the thing that it's pointing to, which is Tokyo. And so notice we can mix letters and numbers and things in the dict. It's a good kind of grab bag. And they're especially great as fast hashes for things. We'll talk about hashing functions later on. All right. And so I'll let you go through some of that on your own. Sets they're fine. I only use sets when I don't want duplicates of things. And so like in this example, I define a list that's got a bunch of duplicate numbers in it. And if I want to know, just what are the unique numbers in there, you can just cast it into a set and then cast it back into a list, and the set thing will get rid of duplicates, which is fun. All right, so loops. Got a thing on loops, and you know what? I use loops from time to time, like for I in range. But if we can think of a vectorized way of doing things, it'll be a lot faster, right? So for example, here's another one, bunch of random numbers. And then let's just calculate the mean of those numbers, and we'll use the vectorized operation to calculate the mean, right? The average. And so this is going to take a little bit, but okay. So you kind of saw this when I ran that other example before. Here's one where I've manually written out how to calculate the mean, as you might in some other programming language like C. And yeah, that's going to take a while. So we can come back and check on that. All right. So as an alternative to loops, either using these sort of predefined vectorized operations or list comprehensions are really good. And so what you do with a list comprehension is you're actually kind of making a one-liner of a list, and you have like f of x for x in y, where y is something that's already defined, x is a dummy variable, and it'll loop through every element of Y and it'll call that element X, and then it'll do something with it that you can define. And that's super fast and easy to write. And so I'll give you some exercises below on that. And then, yeah, range and enumerate and zip. These are good. Okay, I didn't do a comparison. I'll come back to that. But yeah, the list comprehension is generally the way to go on a lot of things. For plotting stuff, we'll generally use matplotlib. I have some stuff that uses Plotly and Bokeh as well. There are a lot of different Python packages, but kind of the canonical one is matplotlib and the pyplot subset of matplotlib. And so here's an example of plotting something. Oh, so this thing hasn't executed yet because we're still doing this one. So if we want to stop this, we can either press that little guy there, that little stop button, or we can go up to runtime and do interrupt execution, or we can do Control M I. So for example, Control M I, and boom. Okay, it's as if we press the stop button, and now it's going to complain, hey, keyboard interrupt. That's all right. We don't care. So now we'll go back up here. We'll rerun this, and hey, check it out. You know, we got this sample thing. So you can use that when you want to plot stuff. Talked a bit about pandas, which is kind of part of the data science stack for Python. Pretty much we're going to use pandas just for reading in files like CSV or JSON, and then use it for other things. Scikit-learn, some of you may have used that. It's a great machine learning package to try out all kinds of things, including it can do neural networks. And yet, since we're going to focus on deep learning in this particular course, we're not going to be using scikit-learn as much. We'll mostly stick to PyTorch, a little fast AI, maybe some PyTorch Lightning, so forth. So what comes after this is practice exercises. And so I think I've got a few exercises for you. And so this is kind of how our other exercises in the course and assignments are going to go. Is there's going to be some code like a function, and the function name and the arguments are going to be given, and you're not supposed to mess with those. And then there's going to be kind of a fill in the blank part where you're going to fill in the blanks with what you think it should be, and then even the return. So there's a little blank there. You're going to want to fill in what gets returned as well. Okay, and then I'll have some code where you can check it. So all this stuff, these assertions, the assert things, it's going to call that function, which is called square half. I'm going to give you like some examples. And then the asserts are going to check to see if this thing that you wrote behaves the way it should. And if it doesn't, you're going to get some message like, oh yeah, here's the message if you did, you know, if this property isn't satisfied. Okay. And then I even have a little time check in case you did it slow. Again, if you're having trouble or if you're intimidated by the timing, don't worry about it for now. But I think it's an interesting challenge to try and get your code to be fast. Okay, so a lot of times this will be how things will get done, and I'll have some asserts in the notebook so you can check yourself. And then also we're gonna have some auto grader type thing like GitHub Classroom where you'll upload an assignment code and it will run its own set of asserts, calling the functions that you've written and then checking to see if the outputs are correct given the inputs. All right, and that's how that'll go down. So a few other exercises, kind of fill in the blanks and some asserts to check. And you know, if you get this all checks passed message, which you have to run this yourself and see how it comes out, you'll see. So a few more exercises that you can mess with, and that'll give you just some sense of checking on your Python. Right? So this has been a while. I'm going to stop the screen share and invite you to check that out. And yeah, let me know how you're doing.